the same idea as yesterday, except it's not a closed interval. It's not like between 2 and 4 or something. It is from negative infinity to infinity. What's with the computers? You guys finish up like a con problem or something? So I still want the absolute max and absolute min. And it still happens at like endpoints and critical points, but the endpoints in this situation are negative infinity, so it just gets, it looks a little different. But we're still going to find the critical points first. So take the derivative. So just kind of rewriting this original, it's like negative 1 half x squared. Like negative x squared over 2 seems to mess people up sometimes. So then the derivative is negative x plus 3. Set that equal to 0. And then if I solve that, I will get x equals 3. So I'm going to check 3 to see what the value is. I'm going to check negative infinity to see what the value is. I'm going to check infinity to see what the value is. So when I say value, I mean y value, right? I'm plugging back into the original to get the y value. So go ahead and plug in 3. Let's start there. I think it's 3. 0. Oh yeah, 0. And then you're gonna like plug in a giant number. So if you think about plugging in infinity or negative infinity, all you really care about is the sign, and all you really care about is the highest power. So it's sort of like horizontal asymptotes. So these don't have any impact because they're not the highest power. The divided by 2 won't really have any impact because if you take infinity and divide it by 2, it's technically still infinity because it's just like a gigantic infinite concept divided by 2 is still a gigantic infinite concept. So you just worry about the sign really. Well, if I plug a negative gigantic number in there and then square it, it's going to be positive or negative. Positive, and then there's a negative in front, right? So I get a negative infinity for my y value if I plug in that. Take infinity and plug it in. If you want to think about plugging in like 10,000 or some big number, that might help. I don't know. But take a big number and square it, big positive number and square it. What do you get? Positive, and there's a negative in front. So the thing you gotta realize here is what's the biggest y value? Where's the absolute max? This one, right? There is no absolute min. Because infinity or negative infinity can't be a minimum. So if you say, like I'm saying, absolute min means that it's the lowest y value on the entire graph. So you say to me it's negative infinity. I'm saying, okay, what about negative infinity minus 2? That's 2 lower. You're like, okay, if you're going to be a dick about it, negative infinity minus 10. You're like, okay, fine, jackass. Negative infinity minus 100. And like, we can just keep going and going, right? So there's no spot where you can say, maybe we can be nicer to each other about it, though. There's no spot where we can say, like, that is the lowest, because it's a concept, not a number. So whatever number you try to say is the lowest number, I can make one lower. And you can make one lower. And I can make one lower. It works the same on the upper end also, right? So like, what's the biggest number you can think of? Okay, great, square it. Okay, great, add 1. Multiply by 100. 17. So, infinity and negative infinity can't be maxes and mins because they're concepts. They're not bounded. Does that make some sense? The highest number you can? Oh, they did? What if you got up to like, I don't know, what if you could just keep going? You're like, I don't know, I got to 4. Right, what's up? So let's look at the next. Well, because there might not be a max either. So like if we look at the next one, I think it happens in this one. So if I take the derivative, 3x squared minus 6x equals 0. So if I factor out a 3x, I get x minus 2 equals 0. If I solve those, I get x equals 0 and x equals 2. So I've got negative infinity, I've got a check, and I've got infinity to check, and I'm checking those because those are my quote unquote endpoints. Even though they're not really points. And then I've got 0 and 2 to check because they're critical points. So I'm going to put all of those back into the original. So if I plug in 0, I get negative 2. If I plug in 2, so 8 minus 12, I think I get negative 6. And then if I plug in negative infinity again, you only care about the highest power. Well, if I cube a negative gigantic number, what does it come out? A negative gigantic number, right? So negative infinity. And if I cube a positive gigantic number, it becomes a more gigantic positive number. So in this case, like these were basically irrelevant because, and this graph goes like this, right? X cube graphs look like that. So there's not an absolute max where you can say that point's, that's a really good graph. There's not a spot where you can say there's the biggest point on the graph and there's the smallest. Where this one was a parabola, and you can say like yes, that point is bigger than every other point in the entire graph. But this one you can't say that. So I found these 2 points, and those are like my critical points, and that's like this and this. But it's not the absolute max. So in this case, there's no min and no max. Does that answer you what you were trying to get at? So say your question again. There was a maximum, right? Am I missing? Okay. I'm sorry about not understanding. I'm not trying to like ignore your question. Should we keep doing them? I'll keep going. If you're good, then you're good. I'll keep going. Let's number 4. It's a little bit. It's a quadrat. It's a quartic. So maybe that's a little different. So again, I'm going to find critical points. Set that's my derivative. Set that equal to 0. I can factor out a negative 4x, which will give me x squared minus 1 on the inside. And then I can factor that into x plus 1, x minus 1. You with me? Yeah, sure, yeah. So I can get x equals 0, x equals negative 1, or x equals 1. So I'm going to check those points along with infinity and negative infinity. Both of these, so both of the infinities, if I plug them in, because it's a 4th power, no matter what I plug in, the 4th power is going to turn positive, right? And then there's a negative in front of it, so these are both negative infinity. So there is no min. But there's going to be a max. So that means I got 2 arrows going down on either side. So there's no min, so it just goes down forever and ever and ever. But the critical points are necessary because that's what's going to help me find a max. I think that's what you're trying to get at. If I didn't find the critical points, I wouldn't know where the max was. Maybe it's not. So let's plug these in to the thing I just crossed out. I don't know what it was anymore. What was it? Negative x to the 4th plus 2x squared minus 3? So if I plug in 0, I get negative 3. Plug in 1, I get negative 1. And so those are your only options for the biggest point and the lowest point on the entire graph. So the lowest point is negative infinity, so there's just not a lowest point because that's on either side. I got arrows going down forever. But where's the biggest point? It's a tie in these two spots because that's the highest y value that we have, so therefore it's the highest y value that ever exists on that entire graph. I'm having trouble telling if you guys are picking up what I'm putting down or what. Give me like thumbs up, thumbs down, sideways. Flip me off if you're in the mood. I don't care. Okay. What's up? That graph would be one of like these guys. So there's your down forever. There's like your negative 1, comma negative 2, your 1, comma negative 2, and your 0, comma negative. So this is like a relative max, a relative min, a relative max. And these are the biggest the graph gets. As far as the lowest the graph gets, it just goes forever, so you can't say there's a lowest point. Yeah. No. The point is that we can find this stuff without the graph. That's what we're going for. That's what we're trying to do. So. So the technical phrasing would be the max is negative 2 occurs when x equals like plus or minus 1, you could say. Or you can just put points. Either way. Yeah. It's still a relative min. It's the bottom of a local hill. It would be like I'm standing here, you're standing here, Ethan is standing here, and then there's a bunch of like kindergartners over here. So in between me and Ethan, you're the shortest. But like you're not the shortest of the entire list of people. But in that weird example, the kindergartners can just be negative hot, negative tall forever and ever, and just keep getting shorter. So that didn't really totally apply. But does that make sense with like the low? A relative is just like compared to what's next. So here, let's look at this one. Set this graph. Just stay with me for a second. Is there an absolute min? Like I can say that is the lowest point of the entire graph. No. What's that? A relative max or a local max. You can call it either one. What's that? Local min, relative min, relative max, local max, relative min, local min. This is a relative max, and isn't it also the absolute max? It's like the biggest y value in the whole graph. And then, again, there's no min. Is that also? Like this point here. There's like applications of it where you want to say, for example, I'm going to build a box and I want to maximize the value. So I'm going to say max instead of min. That's the same idea. Or I'm going to minimize the surface area of the box. And like the graphs might go down forever, but it's not like it's like negative numbers, like negative dimensions, and it doesn't really matter to me. I'm just looking like in this possible window, what's the biggest, like the best or worst I could do, something like that. So that could occur at endpoints or critical points, and we'd have to check all that. That's like one of the things we're doing after this. It's called optimization. So you'll see like a more practical application of it. Yeah, Mr. Zeller. One over x goes like this. No, because if you say, okay, so what's the smallest point? That's 0, but not quite 0. Whatever number you say, I can give you a number between that and 0. And then you can choose one between that and 0. It's like if I go halfway to the door, and halfway to the door, and halfway to the door, I'll never actually get to the door. So you can't say there's a lowest point, because whatever you say, I can say one's lower. So in this example, there's no max organ. Is that good? Okay. Other questions? Caleb, you right? Question? Oh, you don't like that? Sorry. I won't say you don't like it. Do you have a question? No, I don't know if he's serious or like. What's your rapper name? Are you trying to figure something out still? Or are you okay? Gotcha. Okay. I really want to know your rapper name now. I want to know the rapper name. Oh. Yes. Oh, that shouldn't be on there. You can skip number 8. They don't really ask about those. That's not. It's supposed to be negative infinity. Is that the same deal? You can skip 9 also. You can skip 8 and 9. It's just not like no. They either ask like between this and this, or they say like negative infinity to infinity. They don't really get into like mixing and matching. That's the same with your con. You'll see in the con, you have one section that's like on a closed interval, and then one section that's called global, so it's all the way